All right, good morning, everyone. Good evening, good night, whatever time you are tuning in to this session. We are continuing on our journey through nutrient cycles, energy pyramids, and also we're going to look at our other two pyramids today, the pyramid of numbers and that of biomass. So if you're an HSB student, this is actually one of the sections of your assigned topics for section A within your HSP syllabus. All right, so let me just share my screen and we can get right into part two. So we did part one, and part two is to follow part one. All right, so let me just share my screen and we get going. All right, wrong screen. Let me just share. Okay. All right. So on the last day, we started speaking on the last recording, we started speaking on food chains, food webs, and we mentioned that there are two types of webs, those that are on land and those that are in water. And I said to you that you must be able to capture those webs that are on land and those that are in water. Right? You must be able to draw one, pull things out and pull things apart from these joints. All right, let's bring it as big as possible. All right, so this is a typical food chain and food web from on land. I think we would have gone through this one. And I said to you that they could bring questions that they could ask you what will happen to the food web or chain if an organism is removed or one is added, right? So any added or removed from a food chain or web will disrupt the cycle, right? It will cause a disruption, right? So based on where the organism is placed within the web or the chain, that's where the disruption will be, right? So for example, if the deer is removed from this web, then the cougar will only have the rabbit to feed on. So we expect that the rabbit population will decrease, right? As so if the rabbit population decrease, then less grass will be eaten, and since the deer is no longer feeding on the grass as well, less grass will be eaten by these two organisms, so more will be available to the others, right? But the cougar will lose a food source, so they maybe have to find another food source. And if the cougar's food source is decreased, then their population can also decrease. So you have to know, and you hear me using words like decrease and increase, because those are the kind of words you have to use. Tell me who decreases, who increases, and how the entire cycle is affected. All right. After the terrestrial chains, we also have aquatic chains. So aquatic chains are those that are in water, not just sea salted water, but fresh water as well. So it also includes lakes, ponds, and the ocean for saltwater aquatic systems. All right. What I mentioned this to you before, the aquatic systems, they tend to have um, four or more trophic levels, and we say that trophic levels are feeding levels. And there are many reasons to account for that. Number one, in water, they don't lose as much energy along the chain due to heat, right? Because obviously they are in water and they don't lose as much energy due to heat. So there's more energy to go along the chain. So therefore, more organisms can receive energy in terms of having more levels, right? So this is a common question: why the land food chains tend to only have um, four trophic levels, and in the sea or the aquatic systems there are more. For example, look at this chain. We have the freshwater shrimp, right? So this chain didn't start as a producer, but it started at the shrimp. But we know the shrimp will eat um, some sort of supply. But we start at the shrimp here, and then we go to the bleak, the perch, the northern pike, and the osprey. And I would have mentioned to you all before that in aquatic systems, they sometimes are birds at the end of it, and it's because birds will eat the aquatic life, right? Such as the fish and the different things, right? So don't be surprised if you see an aquatic system with like a bird or a human, because we eat fish, at the end, or some other animal, a bear, polar bear, or some other animal that will be on land that will partake in the aquatic life, right? So we see where they have more than the four trophic levels. So they have more than the primary, secondary, tertiary, quaternary. They have more, right? Because less energy is lost to heat, so therefore more energy is passed along compared to what would happen on land, right? So yes, please learn some of the typical plants you see in the aquatic systems, typical names of organisms, because they can ask you to do a chain, and I'm gonna give you all a test. You all haven't been tested. Um, only biology got their first test, so you all need to be tested. So you're gonna have a test in December on cells, transporting cells, and we could do this as well, right? So I'll set you a date so you'll know when you have your December test. Please start studying. All right. So this is another example: phytoplanktons, algae, and we have the zooplankton, small fish, squid, sharks. So they have tend to have more than the four, right? So learn some of these common names. Remember, the arrow is drawn in the direction of the feeding, right? So you don't draw the arrow the opposite way, right? So the arrow always starts at the producer and it continues ahead of the on the chain. Okay? All right. So this is an aquatic chain. All right, and this is an aquatic web. So we have the phytoplanktons. Feel free to pause at any time to take notes, as well as it will be in your classroom, which has been sent to you. All right, so we have the phytoplanktons, the zooplanktons, which is eaten by small fish and crustaceans. So crustaceans are like your lobster and your crab and your shrimp. And um, then we have the large fish feeding on the small fish and the crustaceans. We have even the whales also feeding on the large fish, also on the zooplanktons, right? So this is a web that we can pull on, right? So you're gonna see past paper questions that we're gonna practice eventually on these topics, all right? So let's move on to we should have another note just now. All right, let's move on to our pyramid of numbers and biomass. So far, we looked at the pyramid of numbers for we looked at the pyramid of of energy already. All right, so we have two more pyramids to do, and we finished. So this is going to be a short recording, right? Very short. So we did pyramid of energy. We said a pyramid of energy is a diagram that basically shows how energy flows through a single food chain, right? But now we have the pyramid of numbers. Please take a note. The pyramid of numbers is a diagrammatic representation that shows the number of organisms at each trophic level, underlining number of organisms. All right. So the number of organisms at each trophic level. When we do pyramid of numbers, when we count the numbers, we are not counting it based on their size. For example, one tree is one tree. It's not because it's a big tree you will represent it as more. A tree is a tree, right? An insect is an insect. It doesn't matter if it's small, it's still one. All right. So we don't take into consideration size of the organism, just the amount. All right. And I want us to note that the height of each bar, right, that represents a trophic level is the same. So the height of the bar is the same, but the width tells us the amount of the organism. Let's look at this one. So we have a tree. So we have a single slender bar there because we are talking about one tree. Now, insects in that one tree, we may have about, say, 5,000 insects. So you see that the width of the bar represents that 5,000. And then we have a smaller number of birds, all right? We have a smaller number of birds, right, that will feed on the insect. So this is a pyramid of um, of numbers, and I could just draw you the food chain to go with this pyramid, right? So the first organism was the oak tree. So they could ask us to draw a food chain and a pyramid, right? So this is how it will look. We have the insect. They could draw the pyramid above the food chain above the pyramid, and then we have the bird, which is the woodpecker. So how they could bring this question in the exam is that they can bring you a table with the different organisms name and the amount and ask you to draw a pyramid, right? So they could tell you one tree, they could tell you 3,000 or 300 insects and 50 woodpeckers, right? And then they ask you to draw a pyramid. So you already know, because it's one tree, the bar going to be slender, the amount of insects is more than the woodpecker, etc. All right? So please note that as well, right? And this type of pyramid, we tend to call it inverted. I told you all before that the pyramid of energy is always upright. So small at the bottom, small and big at the bottom, sorry, small at the top. That's the pyramid of energy, right? That's how it is normally is. It's normally upright. But the pyramid of numbers on land can be inverted, meaning that it doesn't have this regular shape of small to the bottom and large at the top. It may have some irregularities in shape, right? In terms of this being small, then big, then small, right? This is another one. Grass, the amount of grass per area is larger than the amount of the rabbits that would eat that grass. But then the rabbits may have more fleas on them compared to the amount of rabbits. So I want us to note that the pyramid of numbers only take into consideration the numbers. And I want you to write the food chain for this one as well. Try your hand at it. Remember, the producer is always the first organism in the chain. Remember the direction of your arrows, right? And this is how the pyramid of numbers can look, right? Um, but I want us to note that the pyramid of numbers in aquatic systems, they tend to be upright, and I will explain why. So the pyramid of numbers in the aquatic system, they tend to remain upright because they are in water, and the organisms that are in the water for producers tend to be small but numerous, right? Because you never see a tree in the ocean, right? You never have a small, slender bar because there's no single tree that you can put in that chain, in that pyramid. So the aquatic plants are numerous, but they are small, but they are still numerous. And we are just counting number or coverage, right? So the coverage of the aquatic plants is a lot, and then the organisms that will feed on it is also a lot until we get to maybe a large bird or a large animal, right? So please note that the pyramid of numbers in aquatic systems tend to always be upright, that pyramid, and upright meaning that the producer is more than the top tier consumer, and it tends to have that regular shape. All right, and it's because the aquatic plants are a lot, right, in order to feed the organisms that is feeding on them, right? So that's a good point to note as well. Aquatic food chain, I mean, pyramids of numbers can be upright because the producer is always in large amounts, though small, but it's still a large amount and it's numbers we're dealing with. All right, good. So this is how the pyramid is. Please pause the video at any point, and this note is always on your classroom. I'm going to send you the directed note so you can take your notes. Guys, do not procrastinate and say, I'll do it weekend, you'll do it next week. You don't have time. All right. And the last pyramid we're going to talk about is the pyramid of biomass. All right, so the pyramid of biomass is a diagrammatic representation that shows the total mass of a particular organism or living matter at each trophic level along the chain. So this one takes into consideration biomass. And biomass, we work it out by finding the total number of organisms at the level multiplied by their mass. So for example, if we have an insect that is weighing 10 grams and we have 2,000 of those, the biomass will be 2,000 grams. And we also take into consideration the location, so maybe per meter or whatever the case may be. All right, this pyramid is more accurate in indicating how much energy is passed along the trophic level. All right, we tend to use this one more when making general consensus about a particular place, but the others are used as well. All right, so the biomass pyramid is one that, as I said, takes into consideration the amount of organisms and their mass. All right. Um, Sometimes the measurements are given in calories per meter. Right. It could also be given in a weight per meter, a mass per meter. All right, grams per meter, kilograms per meter, right? So it's based on the pyramid, all right? So this pyramid shows energy production levels at each level, and it's a good indicator, right? That's how we give it it's a good indicator to make consensus about a particular area. All right, so this is a pyramid of biomass, all right? I want us to see here that because it takes into consideration mass, though this may be one tree in the pyramid of numbers, a tree would have been a single stick like that. But because we are considering one tree multiplied by its mass, its base is bigger in this pyramid, it's upright, right? And then we have the caterpillars, right? So though they may be smaller than the bird, the amount when you multiply it by the mass makes it a greater amount, right? Then we have the birds, and then we have um, the top tier consumer, right? So this is an upright pyramid. Please remember, upright pyramids have regular shapes like this. But in the aquatic system, contrary to the what we saw when we looked at the pyramid of numbers for aquatic systems, the pyramid of biomass tends to be inverted. Why? Though the plant is small and it may be in a large amount, when you multiply it and you do it per area, it tends to be a smaller biomass compared to a big shark or a whale or even a big bird that is feeding on this particular organism. All right. So when we look at the aquatic systems, most times the pyramid of biomass is inverted. So this is a unit, right? So grams per meter squared. All right. So we saw that the plant, well, the producer, which looks like a phytoplankton, um, has a lesser biomass per area than compared to the shark, right? So please note that as well. As I said, we'll do some questions on that as well. All right. So these are our pyramids. Please take your notes. Please take your notes. All right. There'll be a worksheet attached. So please ensure to get it done and have it submitted by no later than Saturday. So today is Thursday. No later than Saturday, have those notes submitted. All right. So I will just show you again the note. It is found in section A notes, the pyramid of numbers and biomass, as well as nutrient flow. All right. There is a worksheet that's on the classroom for this. So I will just also send you the link to that. Get the worksheet done and submit it for me. All right. So all the best in your self-paced lesson for today, and I will see you all next week. All right. Have a good rest of your day, and we'll connect.